Yeah, sure. So I've never really talked to a flat Earth person, but that would be fun. But the what does come up for me because doing molecular and more biological stuff is there's a lot of misconceptions and things that have maybe been pseudoscience and have bled over, and kids kind of think these things are real. It could be things from anywhere, anything from like, should you take vitamin C when you're sick, to issues with vaccines and things like that. But the interesting thing is that I come as a person who has access to explaining and using these like beautiful and complicated structures that are deposited by the world's scientific apparatus into this thing called the protein data bank. And I can show these just like unbelievably amazing looking things that are just beautiful. I mean, this is the reason that I changed from music to science, because I saw a poster for one of these things as some kind of PhD talk, and I was like, I have to know what that thing is. It's these like rainbows, complicated structure with twists and turns in it. And what happens is they, any kind of quick answer that these kids might have heard that is maybe a misconception or pseudoscience or whatever, like this is way more interesting to see, like, what is that? Like, that's what the kids want to learn about. Like, that's way more attractive than some of these other things. So I don't really ever have problems, trying to convince kids or any, no one, I don't think anyone like wants to challenge me, honestly, because it's just such a beautiful and just looks so good. It just obviously is real. And there's so much of it that we just don't have a problem with it. So that's really what draws kids in, I think, is actually seeing these things and realizing their explanatory power, because these other things don't really have a lot of, the power is very minimal compared to what I can offer them.